In this video, I'm just showing you two subtle tricks that can just make life a lot easier in this section of similarity and proportionality. And so, like we said in the Magic Tricks series, I would begin every question by, at the top right-hand side of my page, just writing any lines that I've seen that are equal. And so, you might have a setup like this, where you've got the diameter and the radius. And so in this case, this would be quite a lot, but I would just say AO equals OC equals OB radii. And so you're just aware that any of those can be replaced with each other. And then I could do any of them, but I'm just going to do one of them. Just an awareness that the diameter will be double any of these. So in the middle of the question, if you're seeing ratios like AD times DT equals 2 OC times BD, something like that, it can be a bit nerve-wracking to suddenly start seeing numbers in these rearrangings. And so just cast your eyes to the awareness of the diameter will always be double the radii. And so this, as an example, could just be a simple little replacing it with the diameter. And then maybe when I rearrange these fractions, I'm back on the bus and able to prove whichever triangles they're needing similar. So that's the one trick with diameter. The other one is you might be in the middle of a question and you've got to work out something crazy like this, and you're wondering, wow, that's a lot of information. I don't even know where to begin proving that which triangles are similar. And again, you might end up just, for me, when I see squares, like I've said here, it could be that I've got to do a bit of rearranging and think of this as an AB times another AB. It could just be good old-fashioned Pythagoras. And so I'm going to look for, if I could do Pythagoras, so in this little picture I've drawn, there was a diameter. And so I needed to know that opposite diameter angles in semicircles 90 degrees. Or maybe I had a tangent, and tangent to the radius or tangent to the diameter is 90. And so just look out for those 90s that they probably wouldn't have written there for you, but you've got to know the relationship. And if this was the case here, AB squared, which is like the hypotenuse, minus BC squared is the reverse way of doing Pythagoras. So this bottom would just equal AC squared. And so I'm not going to continue with this question because I've just made it up as I'm talking here. But this might enable you a little bit easier to work out which triangles you're trying to prove similar. And so remember to start every question in similarity and proportionality by writing which sides are equal, or in this case double. They always are helpful. And look out for when there's squares, that there's a good chance it could be Pythagoras or just rearranging ratios. I hope that you found that helpful. If you did, please like it, subscribe to our channel, and share it with a friend.